So let's try some examples integrating using the 1 over x rule. The integral of 1 over 3x dx. Now there's two ways we can do this, and they're going to look different, and then I'm going to show you why they're actually still the same. So this is 1/3 of the integral of 1 over x dx, which is 1/3 of ln mod x, maybe I should write my l's this way, ln mod x plus a constant. And in fact, because this is a constant, a third of a constant is still a constant, we actually usually just write 1/3 ln mod x plus a constant. Now I've called that one C1. We normally just write this. We don't normally even bother with those brackets because 1/3 of a constant is still a constant. But let me show the other method. The integral of 1 over 3x dx. I'm going to use my rule for 1 over ax plus b. And my rule says it's 1 over a times the ln. So here a is 3, so it's 1 over 3 ln mod 3x plus a constant. Now wait a minute, how can it be this and also be that? How can these two things be equal? Well, it all comes down to what the constant really is. Have a look at this expression. This is 1/3. This is a log of a product. So it's the log of 3 plus the log of x plus some constant. Well, 1/3 of log 3 is a constant, right? 1/3 ln 3 plus 1/3 ln x plus constant. This is a constant, so it's really this thing, 1/3 ln x. Sorry, I forgot my mods, didn't I? Mod 3 mod x. That one doesn't change. That one can still be a mod. I'm sorry, I forgot my mods. I'm confusing you a bit. Okay, so it's this one plus C2, just trying to avoid confusion with this C, where C2 is C plus 1/3 log 3. So this expression here is really the same as this expression here. The difference is just the value of that constant. So again, we normally just write it without those brackets and we just write this. You can write this. It's exactly the same. It's just what the value of the constant will be. Let me give you another example just like that, where I won't go through all the rigmarole, so you can see how clearly it works. Let's try the integral of 1 over, why not, 6x, doesn't really matter. So it's 1 over 6 times the integral of 1 over x dx, taking the 1/6 out, which means it's 1/6 times ln mod x plus a constant. Or the alternative method. The alternative method is to say, recognise this is linear, so you're going to go the rule, and the rule says the integral of this is 1 over a ln what's inside. And again, these are actually equivalent depending on the value of that constant. A different example. Integral of 7 over negative 3x plus 4 dx. That got a bit messy. Okay. This looks like my linear rule with a 7 here. So it's going to be 7 times the integral of 1 over negative 3x plus 4 dx. Well, that's 7 times something. What's the something? Well, this is still ax plus b. So I can just put in my rule, it's 1 over a, which is negative 3, times ln mod negative 3x plus 4, plus a constant. And again, because everything else involved is constant, I don't have to do anything else with brackets or anything else. It will just work. And later on, I might be determining what this constant is in a particular case. I do, however, want to simplify this. Negative 7 on 3 ln mod minus 3x plus 4 plus constant. One more example. This one looks complicated. The integral of x plus 3 squared over 9x. Well, the first thing we have to do is expand this. It's the integral of something dx. The bottom hasn't changed. The top is a squared. That means it's x squared plus 2 times 3 times x plus 3 squared. Now split these bits of fraction up. That's x squared on 9x plus 6x on 9x plus 9 on 9x dx. Now you don't have to put the brackets in. I do when it no longer looks like one thing, so I don't lose that dx off the side somewhere and forget about it. So this one is, integral still, this one is x over 9. This one is 2/3. And this one is 1 over x dx. Okay, now I can integrate. The integral of x over 9 is going to be x squared over 18. Increase the power to 2, divide by 2. The integral of 2/3 is just 2/3 x. And the integral of 1 over x is ln mod x plus constant.